today we are basically going to deal with Maxwell's loop current method. Now if you might have seen my first episode, I basically dealt with Maxwell's loop current method in equation 1. Now as we know, there are two ways to solve Maxwell's loop current method. The first way is using simultaneous equation, and the second way is to use your matrix form. So today I will be basically taking up the matrix method. Now, before beginning, as I told you last time, there is a shortcut method which was developed. So we will find out the three equations in these three loops. If there are three loops, there will be three equations. If there are four loops, there will be four equations. So, to go as per the shortcut method, we will have to follow the set of rules which was written told last time. So first thing is circle your loop. So this is my loop 1. This is my loop 2. And this is my loop 3. So altogether, I have three loops. So I'll call this as loop 1, I'll call this as loop 2, and I'll call this as loop 3. So loop 1, loop 2 and loop 3. Now, second step to go for the shortcut method. Label your loop currents. So since this is loop 1, this is I1. Since this is loop 2, this is current I2. And since this is loop 3, this is current I3. So altogether, I got I1, I2 and I3, which are my loop currents. Now, third assumption which you have to do is, basically, you have to set your direction. Now, since we don't know the direction of the currents, of the loop currents, we have to assume this in clockwise direction. So, assume the current direction is in clockwise direction. And in order for us to use this shortcut method which I discussed, you basically have to draw your loops, label your currents I1, I2, I3, and then assume all the currents in clockwise direction. It's only then you can do this shortcut method effectively and a speedy way. So, coming back. Solving for loop 1. Now, using KVL in loop 9. So first thing in loop 1, as I told you, the number of voltage sources equals to the number of voltage drops. So in this loop 1, I have 20 volts and I have 5 volts. Now, another thing which you have to remember is, always for your voltage sources, mark your polarity. So I have positive and negative, again positive and negative, again positive and negative, again positive and negative. So mark your polarities for your voltage sources. So this is the first step. Now, using KVL in loop 1. So, I am basically only going to consider loop 1. So, first voltage source I have is 20 volts. The second voltage source is of 5 volts. So, and the other ones I have is, I have a 5 ohms resistor and I have a 3 ohms resistor. So, in I1 is basically flowing in 5 ohms and as well as 3 ohms. So I1 is flowing in 5 and 3. You can see it is a loop. So you have 5 plus 3 is how much? 8. So we have 8 I1. Okay, so I1 is flowing in 5 and 3. But if we see the 3 ohm resistor, there is even a current I2 which is flowing from down to top. So we have I1 and we have even I2. So now I will take the current of the I2 loop which is flowing in the 3 ohms resistor. So it will be 8 I1 minus 3 I2. So now I got my drops. Now my voltage sources, as I said, I have 20 volts and 5 volts. Now I assume the current in clockwise. Current moves from positive to negative. So this is my voltage source, positive to negative. You see the direction? It is clockwise. This clockwise direction is matching with this I1 value. So it is positive. So 20 plus 20. What about V2? Now if you see the direction of V2, it is positive and negative. So here it is positive and here it is negative. Considering loop 2, you can see where my finger is tracing from positive to negative. So this is basically, this rotation is anti-clockwise, which is in opposition to I1. So it will be minus 5. So 20 minus 5 will give us 50. So this will be my equation 1. Now in the same way how we did for loop 1, we will do for loop 2. Now in loop 2, we have how many voltage sources? We have V2, we have V4 and we have V3. And we have 3 ohms, 4 ohms and 2 ohms. Now first thing, I2 will flow through the 3 ohms, 4 ohms and 2 ohms. So I'll add 4 plus 3 plus 2 ohms resistor, which will give me plus 9 I2, which will give me plus 9 I2. What about the 3 ohm resistor? The 3 ohm resistor, also there is current flowing in from I1. It is in the other direction from top to down. Any resistor which is dealing with the other loop, should be taken in minus. So I have minus 3 I1. So this is with regard to loop 1, equation with loop 1, this is with regard to loop 2. Now, what about this? This 2 ohm resistor is dealing with the I3 in the next loop. So again, that will be minus 2 I3. So I got minus 3 I1 plus 9 I2 minus 2 I3, which is equals to, which is basically all your drops. Now your voltage sources will come on this side. How many voltage sources are there? 5 volts, 5 volts and 5 volts. Positive to negative, same direction as that of I2, so it is positive. What about this? Again, positive to negative, same direction, clockwise, so it is positive. What about this? Positive to negative, again same direction, so clockwise. So 5 volts plus 5 volts plus 5 volts will give us 15 volts again. So this is my equation 2. This was done last time as well. If you all have any doubts, you can always refer to video 1 and check the detailed study. So now we will basically go for the loop 3. So using KVL in loop 3. So in loop 3 we have 2 resistors, 8 ohms and 2 ohms. Now I3 is flowing with the 8 ohms as well as the 2 ohms resistor. So I3 is flowing in 2 as well as 8. So 8 plus 2, it will be 10 I3 with a positive sign. It will take a positive sign because we are dealing with loop 3. But now as we see, 2 ohms is in between of I2 and I3. So there is even a current I2 flowing in the 2 ohms resistor. So any current other than I3 loop will be taken as minus. So that's why we have minus 2 I2. There is no I1 because it is dealing with the loop 1. So we have minus 2 I2 and we have plus 10 I3. Now we have to see the voltage sources. We took the drops, now we have to see the voltage sources. If you see, you have 5 volts and you have 30 volts. Now check the polarities. Current flows from positive to negative. So this is in an anti-clockwise direction. So which is in opposition to current I3. So it will be minus 5. What about 30? Positive to negative. Again in an anti-clockwise direction, which is in opposition to the clockwise of I3. So it will be minus 5, minus 30, which will give me minus 35. And this will be my equation 3. So I have minus 2 plus 10 I3, which is equals to minus 35. Now, we all know Ohm's law states V equals to I2. Now till here, equation 1, equation 2 and equation 3, okay, the steps remain the same. So if I want to do for matrix form or if I want to do for equation form, I have to basically get my 3 equations for my 3 corresponding loops. Now I'll basically deal with the matrix form. So in our matrix form we have V1, V2 and V3. And I have I1, I2 and I2. The same way I have R11, R12 and R12. Again, the first subscript indicates my row and the second subscript indicates my column. So this is first row, first column, R11. This is my second row and this is my third row in the first column. Then my second row in the second column, third row in my second column, and same way, third row, third. So now basically we have our matrix mode. Always remember one thing, if you have 3 loops, you will have basically 3 rows and 3 columns. If you have 2 loops, you will have 2 rows and 2 columns. So if there were 4 loops here, then it would be V1, V2, V3, V4. The same way I1, I2, I3, I4. R11, R12, R13, R14, so on to R4. So if you go to see your steps, if you want to do it for equation mode or you want to do it for matrix mode, it will basically remain the same. So these equation 1, equation 2, equation 3 will remain standard. After you complete these 3 equations, you can decide whether you want to use simultaneous equation and find out the values of I1, I2, I3, or you want to use the matrix form. So this step till here remains same. So now once you got your matrix, okay, which is derived basically from Ohm's law, We can call this as a voltage matrix. We can call this as a current matrix, and we can call this as a resistance matrix. Now, resistance matrix can be taken as delta. So, delta will represent your resistance matrix. Now, before we come for the resistance matrix, it is important for us to transfer all these values in equation 1, 2 and 3 in this matrix form. So, we have V1, V2 and V3. So what does this V1 represent, what does this V2 represent, and what does this V3 represent? So if we have equation 1, equation 2 and equation 3. In equation 1, V1 will represent the loop voltage V1. So we have 50, which represents our equation 1. We have 15 for V2, which represents equation 2, and for V3 we have minus 35, which represents equation. In the same way, currents, we have I1, I2, I3, but the values of I1, I2, I3 are not known, and we have to find it out. So we'll keep it as I1, I2 and I3, since they are unknown. Now, for the resistance, R11, R12 and R13. In equation 1, as I told you, this whole line will represent equation 1, this will represent equation 2, equation 3 and so on. So your first value of I1, I2, I1 is representing A. So it will represent the total resistance of I1. So R11 will be A. In the same way, R12 represents I2. I2 is minus 3. So I'll write the value of minus 3 here. And now R13 will represent the value of resistance value of I3. But I3 is not present. So definitely I3 will be equal to the resistance value of I3 will be 0. Since it is in the same way we do it for equation 2. I1 is minus 3, so minus 3 comes here. R22 is plus 9, so 9 comes here. I3 is minus 2, so we got minus 2. In the same way, for equation 3, R31, I1 is not there, so it is 0. R32, which is representing I2, will be minus 2, and R33, which is representing I3, will be. So this here is your resistance matrix. Now we have entered all the values depending upon these three equations. So we have 15, 15 minus 35. We have 8, minus 3 and 0 since I3 is not there. We have minus 3, plus 9 and minus 2 since we have all I1, I2, I3. And we have minus. We have 0 since I1 is not there, minus 2 and 10. So now our resistance matrix is this. So we have to find out the determinant of this value. So delta represents your resistance matrix. Now using your Casio calculator FX991 ES or ES plus, you can directly find out the value of your matrix using the determinant mode. So the value will come up to 5, 9, 8, which is the determinant of your resistance matrix. So you get the value of 5, 9, 8. Now I'll wipe off these three equations because I have already used these three equations in these blocks right here. Okay. So now we basically go for the delta 1. So this is basically our delta matrix which we already found out, which is 5, 9, 8. So this is the value of your resistance matrix, which is known as delta. Now delta 1, now we have to find out the value of delta 1. Now delta 1 is also your resistance matrix, but there is a slight change. You have to replace the first column of your voltage matrix. You have to take the voltage matrix and insert it in the first column of your resistance matrix. So instead of 8, minus 3 and 0, I will have 15, 15, minus 7. The rest remains the same. So the only change what I did is replace the first column of your resistance matrix with 15, 15 and minus 25, which is known as your voltage matrix. Again, I'll just write this. This is your voltage matrix. This is your current matrix, and this is your resistance matrix, which is even known as delta. So I replace this first row with my voltage matrix. So I have 15, 15 and minus 35. The rest remains the same. So minus 3, 9, minus 2, 0, minus 2 and 10. So this is my delta 1. So delta 1 will be 15, 15, minus 35, minus 3, 9, minus 2, 0, minus 2, 10. So I only replace this first column. Again, I'll find out the determinant of delta 1. Again, the determinant can be found out very easily using your Casio FX991ES OES plus. So I go to the matrix mode, insert these values, and I'll get the value as 1530, which is the determinant of delta 1. In the same way how I got for delta 1, I can find out the value for delta 2. Now delta 2 is also similar to your resistance matrix. For delta 1, we replace the first column with the voltage matrix. For delta 2, we have to replace the second column with your voltage matrix. So the second column is replaced with your voltage matrix. So the rest will remain the same. 8, minus 3, 0, and only this second column is replaced by 15, 15 and minus 35. The rest remains the same. So I have 0, minus 2 and 10. Again, I have to find out the determinant. So delta 2 determinant will give me 1090. And in the same way, how I found out delta 2, I have to find out even delta 3. Now, first column is replaced, second column is replaced. So for delta 3, you have to replace the third column with the voltage matrix. So I have 8, minus 3, 0, minus 3, 9, minus 2, and the third column is replaced by 15, 15, minus 35. So again, finding out the determinant of delta 3 will give us minus 1875. So I got 1530, I got 1090, and I got minus 1875. So I got my delta 1, delta 2 and delta 3. From this we can say one thing: the number of delta 1, delta 2 and delta 3 will be dependent upon the number of loops. So if I have loop 1, loop 2, loop 3, if I have 3 loops, I will have totally 3 deltas. That means delta 1, delta 2 and delta 3. If I have 4 loops, I will have delta 1, delta 2, delta 3 and delta 4 and so on. If I have 2 loops, then only till delta 1 and delta 2. Delta will only be the resistance matrix. So I will get delta 1, delta 2 and delta 3 since there are only 3 loops. Now taking it ahead, since I already have these values, I'll rub this main matrix equation. And I can add in a simple formula which will give me the value of I1, I2 and I3. So my I1 value will be equal to I1 is formulating with delta 1. So it will be delta 1 divided by delta. Now this is also similar to Ohm's law. If in case in the exam time you tend to forget, you can always keep this theory in mind. V equals to I into R. Okay? So if V equals to I into R, I will be what? V divided by R. Your resistance matrix is your delta. So your delta will always be in your denominator. Delta 1 will be your voltage. So it will always be I1 equals to delta 1 divided by delta, which is in the same form of V divided by R. So just remember one thing: delta will always be in the denominator. Delta 1 will be with regard to I1, delta 2 will be with regard to I2, and delta 3 will be with regard to I3. So from this formula, taking the determinant of delta 1, which is 1530 divided by 598. So I get the value 2.56. In the same way, I can find out for I2. I2 will be delta 2 divided by the resistance matrix, that is delta. So delta 2 is 1090 divided by 598, which will give me the value 1.82 amps. In the same way, I can find out I3, which is delta 3 divided by delta. So delta 3 value is 1875 divided by the value 598, which is your resistance matrix. So it will give me a value of minus 3.14 amps. So I got 2.56, 1.82 and minus 3.14 amps, which you might notice in my episode 1, which I have already published in, okay, are the same values: 2.56, 1.82 and minus 3.14. So when we solved it even using simultaneous equations, we got the same values. Even by solving it using matrix method, we also got the same values. So your answers will never differ no matter which method you use. Now, after this, whatever steps follow are the same steps as that of your simultaneous equation. Now, since I got your plus 2.56, the direction of I1 that I assumed is correct. Here also I got plus 1.82, so the direction what I assumed is correct. But for I3, I got minus 314 amps, so the direction what I assumed here is wrong. So I have to change my direction, which is again the same follow-up step. So in equation mode, we directly used simultaneous equation. In the matrix mode, we basically have to get it in the matrix form and find out the values of I1, I2, I3. The rest, all steps remain the same. So I changed my direction of I3, and now my I3, which was minus 3.14 amps, becomes plus 3.14 amps since I did the change. In the same way, I will write for I2 and I1 as well. So I2 is 1.82 amps and I1 is 2.56 amps. So I have 2.56, 1.82 and 3.14 amps. Now, I will wrap this up. So basically we want I1 which is equals to 2.56, we got I2 which is equals to 1.82 and we got I3 which is equals to minus 3.14. So I push the value of I1 which is equals to 2.56, I2 equals to 1.82 and I3 equals to 3.14. But however, we have I3 which is equals to minus 3.14. Now, if you get a minus here, that means whatever direction you have assumed is incorrect and the direction has to be changed. For I1 and I3 it's more positive, so whatever direction we have assumed here, which is clockwise in direction, is perfect. So now, changing the direction of I3. So I change the direction of I3. So now my current will hence be I1 equals to 2.56, my I2 equals to 1.82, and now my updated value of I3 will give me 3.14 amps, which is positive in nature because I have already changed the direction in my figure. So this will be my updated values. Now, as usual, we have to find out the current and voltage through each and every resistor. So I have to find out my current in the 5 ohms and its voltage. In the same way, I have to find out the current and voltage in the 3 ohms. I have to find out my current and voltage in the 4 ohms. I have to find out my current and voltage in the 2 ohms. And I have to find out my current and voltage in the 3 ohms. So, I will take the 5 ohms first. So, current in the 5 ohms resistor will be equal to I1, which is 2.56 amps. If you can see the loop, I1 is flowing in this loop. So I1 is interacting with the 5 ohms resistor. There is no interaction with the I1. So my current in the 5 ohms resistor will be I1, which is equals to 2.56, as it is in this loop. Now, voltage in the 5 ohms resistor will be equals to, now we already know Ohm's law. Ohm's law states what? V equals to I into R. So I have my current value flowing in the resistor, which is 2.56, and I know the value of resistance, which is 5. So it is 2.56, that is I into R, into 5. Which comes up to be 12.8 volts. Now in the same way how we found out for 5 ohms, we have to find out for 3 ohms. Now the current in the 3 ohms resistor will be equal to, now here in the 3 ohms resistor, if you see your loops which are drawn, there are 2 junctions which are available. This is the first junction and this is the second junction. So in the junctions there will be basically combination of currents. So you will have a combination of I1 and you will have a combination of I2. In the same way in this 2 ohms resistor, you will have a combination of I2 and you will have a combination of I2. But for these, it is directly linked with I1, 4 ohms is directly linked with I2, 8 ohms is directly linked with I3. So here you will have no problem, but at these junctions, your currents will be different. So now the current in the 3 ohms resistor. Now as we see, we have I1 here. Okay, so I1 is flowing in the 3 ohms resistor. Look at the direction, it is clockwise in nature. So I1 is flowing from top to down. And if you see I2 is flowing from down to top. So we have I1 and I2, both in opposite directions. So it will be, which is higher, I1 or I2? Obviously I1, so 2.56. So it will be I1 minus I2. So it will be I1 minus I2. The effective direction will depend upon which is greater. I1 is greater, so the direction it will follow will be from top to down. Because I1 is greater, so it will be I1 minus I1. We have I1 here and I2 coming from here. So it will be 2.56 minus 1.82, which is equals to 0.74 amps. Now, once we got that, again we have to find out the voltage in the 3 ohms resistor. Now we have to find out voltage in the 3 ohms resistor. Now I got my current. What's my current? 0.74. So I'll write the current value here as 0.74 amps. So I got my current, which is 0.74. I know the value of resistance. So according to Ohm's law, which is equals to V equals to I into R, it will be 0.74 into 3. So I'll write 0.74 into 3. So that will give me my voltage, which comes up to be 2.22 volts. So I get 2.22 volts. Now, in the same way how I found out for the 3 ohms, I will find out for the other pieces as well. We have already found I1, I2, I3, so I will delete these top values. for my other case for the 4 ohms. So again, I'll find out current in the 4 ohms resistor. Now current in the 4 ohms resistor will be equal to I2, which is equals to 1.82 amps. I got the current, so I can find out the voltage. So voltage in the 4 ohms resistor will be equal to 1.82 into 4, which is equals to 7.28 volts. Same way, now I have to find out my current in the 2 ohms resistor. Now again, current in the 2 ohms resistor. Now, here, the current in the 2 ohms resistor is basically a combination of I2 and I3 because it is at the junction. So I'll see the direction of I2. So I2 will flow from here, from top to down. And what about I3? I3 also flows from top to down. So I have I2 coming here since it's clockwise, and this is anti-clockwise. And I3 is also flowing from here. So I have I2 plus I3. So here it will be an addition. Because I have I2 current and I have I3 current adding and going inside this resistor of 2 ohms. So it will be I2 plus I3. Direction will definitely be from top to down because it is adding up. So my direction will basically be from top to down. I have I2 and I3. So current in the 2 ohms will be I2 plus I3, which is 1.82 plus 3.14, which is equals to 4.96 amps. So it is equals to 4.96. In the same way, voltage in the 2 ohms resistor will be equals to I into R. I have the value of I, which is 4.96 into 2, which is equals to 9.92 volts. And the same way, I will find out current in the 8 ohms resistor. So current in the 8 ohms resistor will be only due to the I3 current flowing through the 8 ohms resistor, which is equals to 3.14 amps. So the voltage in the 8 ohms resistor, which will give me 25.12 volts. So I have basically got all the current and voltage values from each and every resistor. So I have the 5 ohms, the 3 ohms, 4 ohms, 2 ohms and 8 ohms. So in this way I can find out the current and voltage values in each and every resistor. Now one more thing I want to tell you here is, if you are given a problem in the exam and it's told to you to basically specifically tell me the current and voltage to the 4 ohms resistor, then you don't need to basically do all these steps. You directly go for the current in the 4 ohms and voltage in the 4 ohms. So you can basically only target those specific resistors which is asked to you in the examination. But this is just a broad method so that you come to know how you find out the voltage and the current in each and every resistor. But always remember what is only asked, for that only you give the value. One more thing which I would like to specify here is, we have now covered the matrix form using the matrix method. In my episode 1, you have seen using the simultaneous equation. If you compare the values of I1, I2, I3, it is the same. So you can solve Maxwell's loop current method using any of the two methods. So you can either go for simultaneous equation or you can go for matrix. But the answer that you get will be the same. So this is how you can solve using your matrix method.